Today we start capacitance. Capacitance of a conductor, or it is also known as capacity of the conductor. It is also known as capacity of the conductor. This is a spherical conductor. This is a cylindrical conductor. This is a needle type conductor. That is, the conductors have different shape and size, and conductor hold charge. Conductor hold charge. The ability to hold charge by a conductor is known as capacity of that conductor. Actually, the meaning of capacitance is it is the ability to hold electric charge. Some conductor hold more charge, some conductor hold less amount of charge. If the amount of charge held by the conductor is more, then the capacity of the conductor is more. It is similar to like our container. If container hold more water, the capacity of the container is more. If the container hold less amount of water, the capacity of the container is less. Now, in these topics, we study about the capacity of the conductor. The capacity of the conductor means ability to hold electric charge by the conductor. Now, we discuss in detail. Now, you see, the potential of a point is now the formula 1 by 4 pi epsilon naught q by r. From this relation, it is seen that the potential depends on amount of charge. That is the source charge. If charge is more and more, potential is more. If potential is more and more, charge is more. So from this relation, we say the amount of charge held by a conductor, the amount of charge carried by a conductor is directly proportional to its potential. Here, if the charge is Q and the potential is V. If potential of the conductor is more and more, then the charge held by the conductor is more and more. This is this relation. Now, it is become a constant. This is V. This constant C is known as proportionality constant. Proportionality constant. And this C is known as Q by V. This ratio, this constant is known as capacitance. This is known as capacitance or capacity of the conductor. Now, how can you define the capacity of a conductor? It is the ratio, the capacity of a conductor is defined as the ratio of amount of charge contained by the conductor to the potential of that conductor. It is also defined this way. If you consider V is equal to 1. If you consider V is equal to 1 or unity, the capacity of a conductor is defined as the amount of charge. The capacity of a conductor is defined as the amount of charge required by the conductor to increase its potential unity. To increase the potential of a conductor by unit amount, the amount of charge required is known as capacity of that conductor. So very simple. The ability to hold electric charge is the measure of capacity of the conductor. If it holds more charge, the capacity of the conductor is more. Anyway, the capacity of a conductor is defined as the amount of charge required to increase its potential by unit amount. Anyway, it is a scalar quantity because charge is a scalar quantity. And its SI unit is farad. SI unit is farad. It is a very big unit because it is measured as 1 farad is equal to the unit of charge is 1 coulomb and it is 1 volt. We already know that coulomb is the SI unit of electric charge, and 1 coulomb charge is a very big amount of charge. That is why if the capacity of a conductor is 1 farad, it is a very big unit of capacitance. That is, if the capacity of this conductor is 1 farad, it means this conductor holds 1 coulomb of charge. And 1 coulomb of charge is a very big unit of charge. We already discussed in the Coulomb's law. Now, how can we define 1 farad? The capacity of a conductor is said to be 1 farad if 1 coulomb of charge is required, to increase the potential of that conductor by 1 volt. Anyway, what is the dimension formula? V. Potential means V. V means what? Again W by Q. Therefore, it is Q square by W. So, the dimension formula of charge is 80. So, it is 80 whole square divided by work is mL square T minus 2. And finally, what is your answer? M minus 1, L minus 2, and T become 4. T become 4 and A square. It is the dimensional formula of, this is the dimensional formula of capacitance. Now, farad is the SI unit, no? Some other unit like microfarad. 1 microfarad is 10 to the power minus 6 farad. Another unit, picofarad. 1 picofarad is 10 to the power minus 12 farad. These are what type of unit? These are commercial. These are practical unit of capacitance, microfarad and picofarad. Because we know farad is a very big unit. It is generally not used. So what is your common unit? Microfarad or picofarad in case of capacitance. Now, capacity of a conductor depends on what? Capacity of a conductor depends on the size or shape of the conductor. The capacity of a conductor depends on the size and shape of the conductor, but it is independent of the nature of the material of the conductor. Your material may be any conductor, but it only depends size and shape of the conductor. It depends on the nature of the surrounding, where the conductors are placed. It depends on the nature of the surrounding medium, where the conductors are placed. It also depends if any other conductor is near the conductor, then it is also its capacitance is also affected. Anyway, now today's topic is this one. This is radius R, this is center. This is a spherical conductor. This is a spherical conductor and charge is Q and radius is R. Our aim to find out the capacitance of a charged spherical conductor. This conductor may be hollow or this conductor may be solid. So first, how much charge is at the surface Q? We know that in case of Gauss theorem, all the charges are reside at the surface. No charges inside the surface. That is why there is no electric field inside the conductor. All charges are only reside on the surface of the conductor. We already proved in case of Gauss theorem. Now we assume the whole amount of charge is concentrated at its center. We assume the whole amount of charge is concentrated at its center. We assume. So what is the potential at any point on the surface? This one. Here R is the radius of the conductor. The potential at this point, 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 all the points on the conductor, the potential are same. The meaning is this conductor is a EQ potential surface. This conductor is EQ potential surface. That is the potential at all the points on the conductor we said. Now, if this is the potential, then what is the capacitance? The capacitance of the conductor is how much? Q by V. Here is Q. What is the potential? 1 by 4 pi epsilon naught Q by R. and finally QQ tensor, it is known as this one. This is the most important formula. This is the expression of the capacity of a spherical conductor. You see, the capacity of a spherical conductor does not depend on the amount of charge. It only depends on the radius of the conductor. As the radius is more and more, as the size is more and more, the capacity is more and more. Its ability to hold charge is more and more. Anyway, one more idea. If the capacity of a spherical conductor is how much? 4 pi epsilon naught into R. Then what is the radius of that spherical conductor? 1 by 4 pi epsilon naught into C. If you consider your capacity is 1 farad. If you consider the spherical conductor having capacity is 1 farad. And what is the value of 1 by 4 pi epsilon naught? You know, 9 into 10 the power 9. So what is the result become? 9 into 10 the power 9 into 1, that is 9 into 10 the power 9 meter. So very simple concept. If a conductor having capacitance 1 farad, whose radius is how much? 9 into 10 the power 9 meter, and it is a very, very large quantity. This radius is near about 1500 times greater than radius of the earth. So what is the radius of the earth? 6.4 10 the power 6 meter. This is the radius of the earth. And if a conductor having capacitance 1 farad, this spherical conductor is so large, its size is so large, it is about 1500 times the radius of the earth. That is why our conclusion is, if farad is a very big unit of charge, it is generally not practicable. If a conductor has capacitance 1 farad, whose radius is this much, and it is impossible because it is very big size, about 1500 times the size of the radius of the earth. Hence, we can say capacitance 1 farad is the very large unit of capacitance. Okay? From next class, we start the other properties of capacitance.